Okay, so we're going over our quiz review for targets 1 through 5. Remember that your quiz is going to be on Tuesday or Wednesday of the second week of school. So let's start off with target 1 where we're simplifying. So there's no equal sign here, so we're just going to work through our simplification process. The first thing I'm noticing on number 1 is this negative outside the parentheses, and I'm going to think about that as a -1 that needs to be distributed. So I'm going to leave this -2x out in front. I'm going to distribute the -1, and then from there we're going to combine like terms. So everything with an x, which is quite a few things here, if I combine those numbers, I get a total of 6x and then -2. So I didn't combine that -2 with anything since there were no other like terms. Looking at number 2, I have two different sets of distribution that I'm going to have to work through. So working through this -1/2, distributing that to the first set of parentheses. So -1/2 times 4xy would be -2xy. And then -1/2 of -10y would be a positive 5y. And then in a very similar way that I did on number 1, I'm going to pretend that there's a 1, so I'm going to distribute a -1 to these terms in the second set of parentheses. And then my last step will be to combine any like terms, and I'm actually only seeing a couple things we can combine. Those two terms both have a y, so that would give me a total of 6y, but the -2xy can't combine with anything, and neither can the -9x. Just remember on number 1 and number 2, it doesn't matter the order in which you write your final answer. So for example, on number 2, -9x could have been written first, and that would still be correct. On number 2, we're actually solving equations, so we're going to get a solution perhaps, but using a lot of the same thought processes as numbers 1 and 2. So on number 3, just like I did on the first two, I'm looking for those opportunities to distribute. So I'm not going to do anything over here on the left-hand side of the equation just yet. Distributing the 8. And then I'm going to combine like terms across the equal sign. So I'm going to choose to add this 24 over to the other side. And it actually cancels it out on both sides. So now I have a -a minus 56a. And I have to get all the a's on one side. So I'm going to add this a over. So this gives me 0 equals -55a. And I know it's tempting to say that this is no solution, but we can continue to solve. To get rid of that -55, we have to divide by -55 on both sides. And so in this case, 0 divided by -55 is actually just 0. So our answer is 0. This is not no solution. And then on number 4, we're still solving, but in this case, we're going to actually solve the equation for h. And there's lots of ways that you can go about doing this. So what I'm actually going to choose to do is to get rid of this 1/2. And so instead of dividing by 1/2, I'm going to multiply both sides by 2. And 1/2 times 2 is actually 1, so those just cancel out. So now I have 2a equals h times b1 plus b2. So remember, these parentheses mean times, so I'm multiplying the h times the sum of those b's. So to break that up, I can actually just divide by b1 plus b2 on both sides. And then notice, since that whole thing cancels out, we just have h left on that right side, which is what we were going for in this problem. So the final answer is kind of ugly, but it still works. b1 plus b2 is in the denominator. And you can leave your answer like that if it makes you feel better to have those parentheses, that's fine too, but that would be your final answer. Moving on to target 3, where we're talking about the rate of change. So one way that you can find the rate of change is in a graph, which is the case on number 5. So remember when we talk about rate of change, we think about rise over run. So to go from this point to the next point, I would have to rise 2, and I would run 1, 2, 3, 4, 5, 6, 7. So rise over run, the slope would be 2 over 7. Two things I would consider in this case. First of all, I would make sure I couldn't simplify 2 over 7, which I can't. And also notice how that line is going uphill, so it should have a positive slope. So all of that makes sense. On number 6, I'm still looking for the rate of change, but now I'm given 2 points. So we do have a slope formula. Still thinking about that rise over run. Our rise is the y, so we do y2 minus y1 over x2 minus x1. And then I'm going to label these points, and it doesn't matter which point you call the 1s and which is the 2s. So I'm going to fill in based on how I labeled. So y2 is negative 11, y1 is 15, so I'm subtracting those. x2 is 16, x1 is 7. Remember to watch out for a case where you're subtracting a negative. I wasn't doing that here, but when you subtract a negative, that would become a positive. So in that numerator, I would have negative 26. And in the denominator, I believe that is 9. So negative 26 over 9, which is answer C. And that can't be simplified either, otherwise you would want to look for the simplified answer. Thinking about multiple choice, just remember your final for this class will be partially multiple choice, so it's always nice to practice some of those problems. Okay, so still talking about rate of change as we go onto the back on number 7. Rate of change from an equation, we would have to have this in slope-intercept form, which would be y equals form. So to get this into y equals form, I'm just going to start doing some adjustments to the equation, starting by subtracting the x over, and now I'm going to divide everything by 3. So remember here, this is negative 1x over 3, negative 1x over 3. So I'm going to write it like that just so I can really clearly see what the slope would be, and that is the slope. So negative 1/3 is your final answer there. Make sure you actually say what the slope is. You don't just put it in slope-intercept form. Negative 1/3 is your answer. And then on number 8, it's asking us to make a table that represents a linear function. So I'm going to go ahead and make a table here. And I'm going to choose x values that are really easy. Make sure that x values you pick, because there's lots of answers here. The x values you pick should be right next to each other. They should be consecutive. So I chose 0, 1, 2, 3 just to make it easy on myself. You just don't want to do something like 0, 1, 3, 4, skipping the 2. Just be careful on that if you're making your own table. And then if it's a linear function, remember it just has to have a constant rate of change, which means a constant change in the y. So if I wanted to start out the y column with a 2, and I'm going to say that the constant rate of change is plus 3, the next y value would have to be 5. And then adding 3 again, 8. Then adding 3 again would be 11. So the rate of change here would be 3. And again, there's lots of different answers. That's just the one I chose to go with. On target 4, we're going to graph these two linear functions. This first one, number 9, should actually be the easiest type of problem I could give you if it says y equals negative 1. Y equals is a horizontal line at negative 1. If it was x equals, that would be a vertical line. On 10, your equation is already in slope-intercept form. So remember your slope is what's in front of the x, so negative 1/3. Your y-intercept, we call that b, that's that last number. So I'm going to start this line at 2 on the y-axis, and I'm going to graph a slope of negative 1/3. So I'm going to go down 1 over 3. And just notice right after this first point, you can already tell that this line is going to go downhill, which is correct with a slope, with a negative slope. So I'm just continuing this pattern all the way across just so my line is as accurate as possible. Remember, if your equation is not in slope-intercept form, you can always put it in slope-intercept form in a very similar way that we did on number 7. And then you can graph from there. All right, so on number 11, it's asking us to reference number 9, and it's asking for 4 things: the domain, the range, the x-intercepts, and y-intercepts, if there are any. Okay, so let's start with domain. So remember, domain is left to right. So if you look at this graph, and I'm just scrolling up enough so I can see the red line up there on number 9. From left to right, that horizontal line goes forever left to right. So for the domain, we can say all real numbers, or I prefer to use that symbol just because I'm kind of lazy. And then for the range is up and down. And notice a horizontal line doesn't go up or down at all. It just stays at that one y value, and that y value is -1. So your range is just going to be y equals -1. And again, just looking at our graph for any x-intercepts, it actually doesn't cross the x-axis at all. So I'm going to write none. And then I'm going to look to where it crosses the y-axis, if at all. And it does cross right there at -1. So I'm going to write 0, -1. All right, so same thing that it's asking us to do over here on the last problem, number 12, but we're just referencing number 10. So on number 10, it was a slanted line, so that changes our domain and range a bit. So on the slanted line on number 10, if we think about how far to the left and right it's going to go forever to the left and right. But it's also going to go up and down forever since it does have that slant that we didn't see on number 9. So in this case, and actually all cases, whenever you have some sort of a slanted line, the domain and range are both all real numbers. Now we're going to see if it crosses the x-axis, and we actually can see that it does cross, and we can see the value is 6. Remember, we can always solve for the x-intercept by making y equal to 0 in the equation if we can't see where it crosses from the graph. And then the y-intercept we talked about earlier is at 2. It's that b value. And there you go. That's your quiz review.